This video is about generating formula for a line when you have the graph. The x is the variable, y is the outcome, so to say, and the letters a and b are coefficients. B is the intersection with the y-axis, because if you substitute x is 0, the value of x on the y-axis, all that is left is y is a times 0, which is 0 plus b, so all that is left is b. So for x is 0, y is b, so b gives the intersection with the y-axis. More difficult to understand in one single glance is the property of a. What a does is it is the gradient, and what it describes is the way that the graph moves. Does it go up, then a is positive. Does it go down, then a is negative. And the higher a is, the steeper the line. Or for a negative a, the lower it is, the steeper. So what a does, if I up x by 1, then y goes up by a, because you multiply it with 1 more. So how do we use this to generate the formula for a line? We're going to see that via 3 examples. So here's a line on a xy set of axes, and we want to know what the formula for this line is. So first thing we're going to do is write down the general form of the formula. Y is ax plus b. And we're going to find out the values for a, the gradient, and b, the intersection for the y-axis. The latter, b, is most easy because you can clearly see that at y is 3, the line intersects the y-axis, so b is 3. For a, we have to look a little closer. We want to know how much the line goes up if x goes 1 to the right. So how much is this? We can't clearly see that because this is not directly a. This is not a good visible point. But what is a good visible point is the point over here, 3,5. So in order to get there, the line has to go up 3 to the right, and it goes up by 2. So if in 3 steps it goes up 2, then in 1 step it goes up 2 divided by 3, 2/3. The strategy for figuring out a, the gradient, is always find 2 suitable points, and one of the points being on the y-axis is mostly suitable. Find 2 suitable points and then find the vertical change and divide that by the horizontal change. And this division should give you the gradient. Be mindful that that is a fraction you often need to simplify. In this case it's not necessary because 2/3 is as simplified as possible. Now the only thing we have to do now is we've figured out the values for b and for a, is write down the formula. So y is ax, so that is 2/3 times x plus b, and b is 3. So to summarize, in 3 steps, first you figure out b, because that's the easiest part. Then you figure out a by finding 2 points and dividing the vertical distance, or the vertical difference between with the horizontal difference. And thirdly, and that is really the easiest steps if you have 1 and 2, but is often forgotten, write down the formula. Let's look at another example to practice these steps. First of all, a line can be written down as y is ax plus b. And we did that in 3 steps. 1 was to figure out the value for b, 2 was to figure out the value for a, and 3 is to figure out or to write down the formula. So b is the intersection with the y-axis. That happens at y is 5, so b is 5. A can be found by finding 2 different points that are easy to read. For instance, 0, 5 on the y-axis just like before, but we could also use this as the first point, 1, 3, and maybe this point 2, 1. First thing to note is that since the line goes up, a should be negative. Then the vertical difference between those 2 points is 2, and the horizontal difference between those 2 points is 1. Now, since the line goes down, the vertical distance is actually negative 2. So mind the minus over here. And then to figure out the value for a, we have to divide vertical by horizontal, or negative 2 divided by 1. So the gradient is simply negative 2. Last step is writing down the formula. Y is negative 2 times x plus 5. The last example is a trick example, because note that the x's are not labeled x and y but b and n. So that means that the general formula is not y is ax plus b, but n is ab plus, well, also b, but let's call that b prime, or b hat, or b star, or anything other than just b, so that I don't confuse it with the b from the exercise. So I'm sticking to b prime, and the only reason why we give this a name is so we can use that name in step 1, where b prime in this case is still the intersection with the y-axis. That is in this case 50. Step 2 is the gradient, finding the gradient. So we have to find 2 points. Well, 0, 50 is a good example, and maybe 8, 250. So then the vertical distance divided by the horizontal distance becomes, and now we have to pay a little more attention because we can't just count the squares or like we did before, because the scale is not the same on both axes. So the vertical distance is 250 minus 50, and I can just write that down like this. And the horizontal distance is a little easier because we start at 0 and we go to 8, but let's write down 8 minus 0 to be specific. So that's 200 divided by 8, which is the same as 25. So each step to the right it goes up by 25, and each 2 steps it goes up by 50, which is more or less correct. It is correct. So the formula becomes n is 25 times b plus 50. Note that in all 3 examples I wrote down the coordinates of the points in the graph itself. Now, sometimes the graph is somewhere where you can't draw, like in a book. Then in step 2, please write down the coordinates you're using to calculate the gradient, so that it is clear how you got these numbers. And as a final remark, and I already said this but I can't emphasize this enough, write down your results.